a refresher of what composite functions are. This is when we layer functions with each other, so like f of g of x. So what ended up happening with these is we had some input, and then we evaluated the output for one function, and then this is where the wording gets kind of tricky, but the output for g of x becomes the input for f of x. So the steps we go through with these is you start with the inside of the function. So you want to work your way inside out. So we first evaluate that value for g of x and get some number out, so that then we would go and look at f of, and whatever that number was, and then we could just evaluate using our function f. But it's a way of working with two functions together, and kind of having this input, and kind of follows this trail of moving along and changing based on the different functions. But the key is to work inside out. Now what we're going to be doing here is layering functions using both the original forms of the functions and the inverse functions. So this can be a little bit of a trick for the brain, because we've been working with these functions in one way, and we've been having a lot of practice, but we need to be comfortable with switching into different forms. So something we want to keep in mind is that when we work with sine, cosine, tangent, and with these, I'm going to focus on the idea of locations on the unit circle. In that last video, we looked at triangles, but it's because we actually saw the triangles and thought about the ratios there. Here, I'm going to focus on the unit circle, sorry. So with just working with sine, cosine, tangent, the idea is that we're being given an angle, and we want to find something related to the coordinate, whether it's y or x or the ratio of y over x. So find something involving the coordinate. Whereas with inverse sine, inverse cosine, inverse tangent, what we're being given inside the function is we're being given information about the coordinate, and we want to find the angle measurement. So with each of these, I'm going to write little kind of notes to myself that can kind of help describe the direction we're going in, so that we make sure we're grabbing the correct pieces. Because what should end up happening is that when we work with these together, is that like when you find the angle measurement for an inverse function, that can be used as the input for a standard function. Or if we find the coordinate for one function, we can use that to find an angle measurement for the inverse function. So there's a way of moving between inputs and outputs here that lets us layer these functions. So let's try this out. So inverse sine of pi over 6. Now starting this, I'm going to completely ignore that inverse sine. My only focus right now is this sine of pi over 6. So what this wants me to find is I want to find my y coordinate, since it's sine, at an angle measurement of pi over 6. So with this, if I grab my unit circle, I'm at an angle of pi over 6. I'm right there at pi over 6. I have my coordinate root 3 over 2, 1/2. And to evaluate sine of pi over 6, I can replace all of that with that y coordinate of 1/2. So the inside of that function there, so I still have this inverse sine on the outside. But what I can do is replace this whole idea of sine of pi over 6. Well, that's just the y coordinate at that angle measurement. So all of that gets replaced with the number 1/2. So we have this replacement of our function and what that output would be. Now what I'm going to do is evaluate my inverse function. So this is where I'm going to switch. So what my inverse function wants to find is we want to find our angle measurement where we have a y coordinate of 1/2. So we're being given the coordinate inside the function, and we want to find an angle measurement. Now, something we need to keep in mind is that when we do this, working with inverse sine, we can only be between negative pi over 2 and positive pi over 2. What ends up happening with this one is we end up at exactly the same location. The idea being, okay, y is positive, so we'd be in the first quadrant. It would be an increment of pi over 6. However, we're looking for the spot where we have a y coordinate of 1/2, which we already used here. It's just what this wants as an output is the angle measurement. So my final solution here is pi over 6. So this function here, it's using the same function, like it both involves sine, it's just one is inverse sine and one is standard sine. And what can happen is that they can essentially cancel each other out. We'd have inverse sine, sine, and we would just have that pi over 6 in there. Now, that happens sometimes, not all of the time, but it's a nice little trick that if we were here, and this happens a lot when layering inverse functions with each other, is that you would just end up with the original input as the solution, as we saw here. So it feels like you can skip steps. However, do not skip steps, because let's look at this next example. Let's say I skip steps here. Let's say I just said, you know what, those are the same function, inverse and standard. We're going to be getting 5 pi over 4 out. And yay, I saved myself so much work. Let's look at the calculator though. What if we plug that in? So inverse cosine of 5 pi over 4. Oops. And we get that out. And what we just said is like, the solution is 5 pi over 4. Oh, and this is tricky because it makes it look like it's the same. However, check the mode out. I'm in degree mode, but I'm working with radians. There we go. It is not matching up. So that trick works sometimes, and it's kind of a nice way to confirm you did it correctly if that is the case. However, if we went too quickly through this problem, we would actually be wrong. I would get no credit. It's an incorrect solution. So let's see the long way of how do we get to our solution. So I'm starting with just looking at this cosine of 5 pi over 4. So on my unit circle, we're at 5 pi over 4. So let's see, we have 1, 2, 3, 4, 5. So we're here at 5 pi over 4, and we're looking for cosine. So what this wants to know is we want to find the x coordinate at the angle 5 pi over 4. So our coordinate, let's see, x and y will be negative, so this will be negative root 2 over, or sorry, with negative root 2 over 2. And we want the x coordinate. So what I can do is this replacement of this whole piece of cosine was looking for that x coordinate. So I still have this inverse cosine on the outside. And it's just what was inside that function. I'm going to make that replacement with the x coordinate of negative root 2 over 2. Now, when we go to this inverse cosine function, this is where it fell apart. This is where we didn't get that kind of nice lining up where we could just have that solution of 5 pi over 4, because inverse cosine has to be between 0 and pi. So what we did here is we went outside of that domain, which we can do, is just we need to get back into that section. Whereas this last example, it worked out with this kind of cancellation because where we started inside of that domain and range of inverse sine. So because it landed in there, it worked out that it lined up. But we need to be careful because there are going to be these cases where we're outside of it and we need to get back to it. So what this is telling me is I want to find my angle measurement where I have an x coordinate of negative root 2 over 2. Now, I can see I have my negative root 2 over 2 down there, but there's another location, and I want to use that other location. So negative root 2 over 2 as an x value also lines up right over here. We have positive y, negative x. So this would be negative root 2 over 2, so I'm seeing that same x coordinate, but it's just within the quadrant that I want to be working in with inverse cosine. So we're looking here, and I need that angle measurement, which is 1, 2, 3 pi over 4. So this whole inverse cosine of negative root 2 over 2 is going to give me the angle measurement of 3 pi over 4. And if I go back to the calculator, let's just change that to a 3. Now my solution lines up. Now it works because we got back into that correct part of the unit circle to work with. All right, so when you layer, or when you make a composite function rather, with the same type of functions, just one's inverse and one is standard, sometimes you'll just end up with what's inside the parentheses there. Sometimes you'll end up not with that value. So it's important to take the steps of just evaluate the inside and then evaluate the outside and just kind of follow the path until you get to the end. Now, what if we made composite functions with different trig functions? What would that look like? So with this one, I'm completely ignoring sine right now, and I'm just focusing on arctangent of 1. So inverse tangent, we're looking to find an angle measurement and we're looking for the location where this ratio of y over x is equal to positive 1. Now, in terms of our unit circle, we talked about how that's going to occur at an increment of pi over 4. I'm working with inverse tangent, so I need to be in this range of negative pi over 2 to positive pi over 2. So it's positive 1, which makes me think we are up here at root 2 over 2, root 2 over 2. So the ratio of those two values with each other will give us a positive 1. So I need the angle measurement. That's what inverse tangent's doing. So that angle measurement is a positive pi over 4. So what we're looking for is sine of, and that entire inverse tangent was about calculating the angle measurement, which we found as pi over 4. So we make that replacement there. Now sine of pi over 4, what we're looking for here is to find a y-coordinate where the angle measurement is pi over 4. So we have this replacement where this calculated an angle, which should be the input for our standard just sine, cosine, tangent functions. So we ended up with an angle measurement, and now I want to evaluate the y-coordinate, which we just saw is root 2 over 2. All of that's going to be replaced by root 2 over 2. And that's our final solution. So it went find an angle, plug in the angle, find y. And that's where these, I keep saying like follow the path, and that's what these are doing. Like this one found a y coordinate, this found an angle. So that y coordinate became the input and the output became an angle. Whereas here it was find an x coordinate, and the x coordinate becomes the input, and then the inverse function finds an angle measurement. So that's where layering these, they work together because the input for one, the output for the other, and so on and so forth. All right, one more here. So this one I'm going to look at sine of pi over 2. And I'm just completely ignoring that outside function for now. So sine of pi over 2. So what this wants to find is we're finding a coordinate. So we're looking for our y coordinate since it's sine, and we're given an angle measurement. So in terms of location, we're up here at 0, 1. So we want to make this replacement. So on the outside, we have our inverse cosine. And that sine of pi over 2, we're just replacing it with the y coordinate, which we found is 1. Now when we work with inverse cosine, we're looking to find an angle measurement. Where, and then what we're given, that's our x coordinate. Since we're working with cosine, that's our x. So just be careful because we kind of switched there, like this was finding a y coordinate. Oh, this is so terrible, but then that became our x coordinate. But it's all because of the actual function we're working with. Because that was sine, it relied on y. Because this is cosine, this relies on x. All right, inverse cosine is happening from 0 to pi. And I want to see, where do I have an x coordinate of positive 1? Well, positive 1 is right here, that coordinate 1, 0. So we're looking at this terminal side, which is an angle measurement of 0. So this angle measurement is just 0. And with these, you can check your solutions, just plug into the calculator. You can layer these within the calculator. Make sure you're in radian mode so it works correctly. But always be sure to check your answer after showing all your work as well.